Welcome friends to this video lecture on the subject Principle of Electrical Electronics Engineering. In the first video we have seen system, then what is a open loop system and closed loop system, advantages of open loop system, disadvantages of open loop system, advantages of closed loop system, disadvantages of closed loop system, and then few examples for closed loop system and open loop system. The second part deals with modeling of electrical system. It deals with modeling of electrical system. Here, in any electrical system, it comprises of three basic elements, that is resistor, R, L, and C. Resistor, inductor, and capacitor. All the electrical circuit, it consists of these three elements: resistor, inductor, and capacitor. You cannot find any electrical circuit without these three elements. Either you will have combination or you will have separate elements in an electrical circuit. By using this circuit, we will try to model electrical system. Here we are trying to model electrical system by using either voltage source or current source. Here we are trying to get the equivalent model of an electrical system with reference to either voltage source or current source. In this system, here we will convert the electric circuit into differential equation. A differential equation is governed. The differential equation of an electrical system is found by writing Kirchhoff current law. By applying Kirchhoff current law for the given circuit, we are obtaining differential equation. After obtaining differential equation, we will get the transfer function of the system. Transfer function is nothing but Laplace transform of output by Laplace transform of input at zero initial condition. That means we need to get the input and output equation for an electrical system, and then if you take the ratio of output by input, it will give you the transfer function of an electrical system. Now this table shows the relation between voltage and current in a resistor. The first block we are having in the first block we are having a resistor. In resistor, the voltage drop across the resistor is defined by R into value of the resistor and current flowing through the resistor. Or otherwise, the current flowing in the resistor I of t is determined by voltage drop across the resistor and value of the resistor. Next we are having inductor. In inductor, the voltage across the inductor, it depends upon inductor value, that is L into di by dt, the current flowing through the inductor. Similarly, the current flowing through the inductor, its value depends upon 1 by L integral of V of t into dt. Next is capacitor. The voltage across the capacitor depends upon 1 by C integral of I current flowing through the capacitor. Then the current flowing through the capacitor is determined by capacitor C value into dV by dt. This table shows the relation between voltage and current in R, L, C individually. This is a very important table. Next, we will have a simple problem. Here, our objective is to obtain the transfer function for the given circuit. The circuit is having a voltage source E of t and two resistor R1, R2, capacitor C1, C2, and output voltage is V2. What is transfer function? Laplace transform of output by Laplace transform of input. That means we need to get an output equation and input equation. In the circuit, the input is E of t, and in the circuit, output is V2 of t. Next, the Laplace transform of input is L into E of t is E of s. This is your Laplace transform of the input, and your Laplace transform of output is L into V2 of t, which will get it as V2 of s. What is transfer function? Laplace transform of output by input, that is V2 of s by E of s. This is our Laplace transform. So this is the transfer function of a network. We can obtain the differential equation of any electrical circuit by applying KVL, Kirchhoff voltage law. So that in order to apply Kirchhoff voltage law, to make the process easier, I am converting the voltage source into current source. In the circuit, it is having voltage source, but here we are having current source. Here the voltage source is converted into current source. Now, in the previously you are having the resistor here. Since I changed the voltage to current source, now this resistor R1 is connected parallel across to the current source. We know that in voltage source, internal resistance will be series. This VR. This can be converted into current source by I is equal to V by R, and this resistor is represented in parallel. Now this is your equivalent current source for your voltage source. This principle we have applied to the circuit, and we have converted the voltage source to its current source, and hence the resistor R1 value has changed from this position to this position. Now this is our circuit. Okay, now in the circuit we are having two nodes, node V1 and node V2. Current entering the circuit is I. Current entering the circuit is I, and these are the current which are leaving the nodes. We are having three currents. I is equal to I1 plus I2 plus I3. I is equal to I1 plus I2 plus I3. We know that Kirchhoff current law states that the sum of current entering a node is equal to sum of current moving away from the node. I value is determined by E by R1. By Ohm's law, we know that I is equal to V by R. One end of R1 is connected to V1, other end of R1 is connected to reference node 0, and hence V1 by R1 plus one end of C1 is connected to V1, other end is connected to reference node, and hence from the table we know that C, the current across the capacitor is C1 into dV1 by dt plus next I3. I3 value is defined by this resistor. Now this resistor is connected across V1 and V2, and hence it is V1 minus V2 by R2. Now we have got our first equation. Next step is to take Laplace transform for the above equation. If you apply Laplace transform for the above equation, you will get it as V1 of s by R1 plus C1 of S V1 on to S plus V1 of S by R2 minus V2 of S by R2 is equal to E of S by R1. If you apply Laplace transform for the above equation, you will get this equation. Then V1 is common. I am taking V1 outside. You will have this equation. Next, now let us apply Kirchhoff current law to node 2. In node 2, you are having resistor R2 is connected to node 2 and C2 is connected to node 2. There is no current which is leaving node 2. All the currents are entering the node 2, and hence on the right hand side you are having a 0 because no current leaves the node 2. And hence the equation is V2 minus V1 by R2 plus C2 into dV2 by dt. We have obtained the differential equation for node 2. The next step is take Laplace transform for the equation. If you take Laplace transform for this equation, you will get V2 of S by R2 minus V1 of S by R2 plus C2 S V2 of S is equal to 0. Our aim is to obtain an equation for output and input. And hence we will rearrange the equation. We will get V1 of S to one side and V2 of S to another side. In this side, V2 of S is common, and hence we will take V2 of S outside. If you take V2 of S outside and multiply with by R1, you will get this equation. Now let us substitute this value V1 of S in equation 1. Now let us substitute V1 of S in equation 1. Where is our equation 1? This is our equation 1. This is our equation. This is our equation 1. Now let us substitute V1 of S in this equation. If you substitute, you will get 1 plus SC2R2 bracket V2 of S into 1 by R1 plus SC1 plus 1 by R2 minus V2 of S by R2, that is equal to E of S by R1. If you rearrange equation, our objective is to obtain Laplace transform of output by input. Laplace transform of output is V2 of S. Laplace transform of input is E of S. Our aim is to obtain Laplace transform of output by Laplace transform of input. If you rearrange the equation V2 of S and E of S, you will get the transform function as this. Now we have successfully obtained transfer function for a given electrical circuit. Thank you for watching this video. The next video will deal with unit 5.